Alright, welcome back. So we were talking about classes. We were putting the class in classes, and now we're ready to recreate something that we did for functions, but this time with fancy classes instead. So all of these functions are going to become member functions. They're going to become methods, and then this is going to become a member variable. It's going to become a field. Okay, so that's all we have to do. Are you ready? So we have member variable. We'll keep track of our current count. So every counter is going to have like counter C, and we can say like C dot init, C dot increment, etc., etc. And this will keep track of this C object, and it'll have a count inside because that's its one member variable. It'll start at 0, and then we'll make it 1 if we say inc. Okay, so that is the idea. We're going to package all this together into an object now, and it has like inc inside of it, and has dec inside of it. All of the methods go with the class because of that fancy, fun term, encapsulation. Yeah? Are you ready? So let's do this. And oh man, this was secretly a getter, wasn't it? Oh man. So that's the point. So without any further ado, let's do this. So let's recreate a counter library. So vim counter.cpp. Maybe I'll be lazy. I think we can at least start. We can at least start with just one big file. Okay? So here's what I would like to do. Make a counter. We're going to init it. Then we'll say c.inc, maybe like 3 times. We'll decrement it 1 time. We'll output the count. We'll say get count. We'll give it this kind of name this time. Then we'll reset it and inc it once more, maybe. Who knows? And then we'll output its get count again. So this should give us back what? 1, 2, 3, 2. And this should give us back 0, 1. Yeah, because reset will set it back to 0. So let's just make this class now. We'll say class counter. Bam, don't forget that. Then we'll say public stuff that we want the user to be able to see, and then private stuff that we don't want the user to be able to see. So the private stuff, usually that goes at the bottom, and what we'll be using is just one thing. It's our count, and that's going to be an integer, right? Int count. Oops, trying to highlight that. Yeah, just int count. Oops. And now we have our methods. What do we want those to be? Well, we need init, reset, inc, dec, and get count. What are the types now? Init will be void. It's just going to operate on the private member variable. Reset, that could be void. It's just going to set it to 0. Again, operating on the private member variable. Inc, again, also going to reset the member variable, same with dec. And now get count is the one thing that's going to return back an int. These touch count. Yeah, they reset it, they give it a new value. This one does not, so it should be const. See that? That's the beauty of it. And yeah, let's go and implement these now. So we can put them down here because we're nice C++ programmers. And we'll say counter : This is counters init, not function. It's a member function. It's a method. Yeah. And then we'll say that. And that. And that. And that. Are you ready? So, init's quite simple. You just say count equals 0. Reset is the exact same thing. It's just the idea is we only call init once at the very beginning once we make our counter. That's the hope. Then inc is going to set the count to be one more. Dec is going to do the same thing, except in the opposite way. And get count will give back the count to whoever asked for it, so we're going to return the count. Okay, that's why we have an int, and the rest of these are void. Yeah. So yeah, everything is not underlined anymore. We have declared the class counter. We have been fancy with our const. We have been fancy with our privateness, and now we have init, reset, inc, and dec, and get count. Notice this is a getter. And init and reset, these are secretly setters. Reset especially. But they control how you set things. They only let you set it to 0. And that is guaranteed. You're not allowed to set count to, like, count can't jump from 42 to negative 42. It's impossible, because these are the only things that you can do. You can set, like, you can set the count in a special way, but you can only set it back to 0. Yeah. And then inc and dec are also kind of setters, but they're more like operations. These are also technically setters, right? And again, they're updating things in a very specific way, where if we just gave free reign to the count member variable, the user could set this to like 42 on one line and 87 on the next line, and we would not be any wiser. So this is quite nice to be able to control exactly what the user can do. We can get from 42 to 87, but you got to call inc a bunch of times. That's the only way you can get there. You see how that gives us control over how our program gets run, how our counter gets used? That's very nice to have. Okay, so yeah, I think this should all work. Hopefully we're going to get 2 and 1 printed out. Otherwise there is an error one way or another. Okay. Counter, counter. Hey, all right, so we got 2 and 1, quite nice. And that about does it. Hopefully this makes sense, how to translate the counter that we already implemented to class form, okay? And we're all cool and object-oriented now. That's the whole point. And so now I want to let you on a secret, okay? I want to let you in on a very important secret. Every method is really secretly a function, okay? It's just a regular function. It just happens to belong to a class, so it's really just a function declaration, but it's special in a certain way. It's special in that even though we say it has no parameters, secretly it does. Secretly it does, okay? It gets a secret 0th parameter, we say, and that is the object itself. So when I say, let's see, here I am in main, and I have my counter. I have my counter C, and it has its count inside of it. And I call dot inc or something. When I say dot inc, technically it gets a secret C sent to it by reference, we can say. And that C, or it's called like self or this. It's really called this. And that is giving me ways to get to this C secretly. That's the secret first parameter, secret 0th parameter. And if you don't believe me, watch this. Init, I know a variable that exists right now. It's called this. Ooh, that's not underlined. Ooh, that gives me a value. What? It really is there, and it's something very special to a method. It doesn't exist in a non-method. It only exists in a method, and that tells you what your current object is. So your secret 0th parameter. Okay, so that's where I want to leave you now. Just enjoy that fact. We'll come back to it. Okay, so let's talk about constructors now, because I have secretly left a hole in our counter class, because I am forced, remember, I am forced to immediately call init right after counters. The counter is made. Otherwise, it doesn't work right? Otherwise, the member variable is set to something random, and then inc won't do the right thing. Yeah. So init, this must be called right after the counter gets made. Otherwise, C doesn't work right. Okay. So that's unfortunate, but a fact. All right. So wouldn't it be nice if we could force C++ to call init for us, so that we don't have to make the mistake of forgetting? And oh man, we do have that luxury. C++ gives us a way to never forget to call init, and it's called a constructor. It's a special kind of method, and it gets called for you immediately after you make an object. You have no choice in the matter, it's getting called for you. Okay? Secretly, one got made for us already, it just did nothing, because it was the default one and it did nothing special. Okay? So the name of the special method, that is the constructor, is the same as the name of the class. So for counter, the counter class, the constructor's name is also counter. Yeah? Weird, I know, but we'll get to it. Also, next weird thing. So we have class counter. Let's make this blue again. So there's plenty of stuff in here. I'm well aware. You can have the method counter inside of it, and it can take as many parameters as you want. It doesn't have to take any if you don't want it to. And you can give it, it's just another method. Weird. And it has no return type. Not even void, you just don't write it. It's extra weird, I know, but it will become second nature, I promise. Okay, so there's no need for a return type in a constructor, since it's technically giving back the counter, the brand new counter that it's constructing. Does that make sense? So that's why there is no return type. It is just called counter. It's giving back a counter too. That's the point. That is technically the type of its return type, right? So that's weird. You can also have multiple constructors, and they can take different numbers of parameters. So here's a counter that takes 2 parameters. Here's a counter method, a constructor, that takes 0 parameters. That's totally fine. You can do whatever you want. Okay? So you can have as many as you want, and then a constructor that takes no parameters has a special name. It's called a default constructor. Okay? It's just called a default one because it doesn't need anything extra to be called. It doesn't need anything special. So, yeah, let's make a constructor for counter. Okay? I just want another bullet, please. Are you ready? So instead of init, how do I want to say this? Init is no longer necessary once we add a constructor. Are you ready? Going up here, going up here. So I'm going to get rid of init. It's gone. It's gone. Here comes the constructor. It's the same name as the class itself. It's called counter. So, are you ready? Let's do this. We can say counter, that's the name of the constructor, and let's make a default one. And this one will set the count to 0. Okay. I have somewhere I'm going with this, I promise. So that's counter. That will replace init. So we say, well, it's counter. no return type. I know, it's weird. Count equals 0. And this gets called automatically for us, okay? This, the default constructor, gets called automatically for us right here. So it goes hand in hand with a declaration. This is secretly calling the constructor, just saying it like this. It's secretly calling the default constructor. And I'll show you how to call the different kinds. Okay, so this is going to set it to 0 now, and everything's going to be the same. It's still all going to work. 2, 1, because the constructor is implicitly getting called here. Okay, let's make another kind of constructor. Let's make a 1 parameter constructor that takes an initial value. So this is another constructor. It's a non-default one. And what it'll do is it's going to initially set count to initial count. Yeah. So if we give it 42, we can start the counter at 42 if we wanted to. You see how I'm doing that? This will construct a counter. It will make a brand new counter with the count set to whatever count the user passes along. Okay? And here's how you call this. The way we get to use that one instead of the default one is like this. Here's counter D, and if we put some parentheses right here, we can use it like this and say 42. Okay? This calls the non-default constructor. Okay, so it's giving a value to that one argument, or the one parameter that it was expecting. It's giving one argument to it. Okay, so initial count will be set to 42 in this case, and we're going to hit this one, this constructor, not this one. Some constructor runs every time you make a class, but you can control which one. Okay, so that's going to set the count to the initial count, and then we can say d.inc, and then we can print it out as well. And this should be 43. You see that? As long as it's D and not C. Okay? Do you see this? This is very powerful. This is default constructor, but the second you try and give arguments to this, it's a weird kind of declaration and then also like a weird function call. It'll grow on you, I promise. This calls the non-default constructor. Yeah. Here we go. 43. That's useful. It's useful to have multiple constructors and to have that kind of guarantee that this is always going to get called. It's very, very nice to have. Okay, so yeah. So let's make a counter default constructor and 1 parameter. Okay, just to make sure that we're documenting everything we do once you go back and study this. Okay, so I think I'm happy with this slide now. That is constructors. They help you initialize things. They are forced to get called, okay? You have no say in the matter. You can write a blank constructor if you wanted to, but a constructor always gets called. You might as well have control over it. So this next brings us to the topic of initializer lists, and the whole point of them is giving you ways to construct things in a fancier way. Okay, it gives you ways to call constructors on your member variables themselves as they get made, which is weird. It's like you have constructors inside of constructors now, and also it lets you set const member variables, which is otherwise not possible. The way you can do these things that you don't know how to do just yet is using what's known as an initializer list. Okay, it's a new piece of syntax, and it looks like this. So what you do is you put a colon after the parameters of your constructor. This only works in a constructor. And then you put a comma-separated list of constructor style initializations. Okay, so this is very weird. Don't worry, it sounds complicated, but I'm going to show you an example. This is essentially what it looks like. You're defining a constructor for a random class. It's got some potentially many parameters, and then you put a colon and a x1 arg1, x2 arg2, optionally a space, and then you can put the body of the constructor. It's very, I know it's weird syntax, but I promise it will make sense. And here's the secret. Here's what you look for. This is what you need to remember. Look for the sad face, okay? That is a initializer list. So I think we've done enough with counters. I'd like to make a new class now just to show you initializer lists. It's a bit complicated. I don't want to add to counter anymore. So I'll make a initializer lists.cpp. I'm going to make a very simple class now. It's going to be a class C, very simple. Doesn't even have a good name. It has one member variable. It's public. I'm breaking all the rules right now. Okay, just for you. You're welcome. So here's a constructor that is going to set C in a special way. So here's what I want to show you. Option 1. Set C to be 0. Set C to 0 normally. Let's do it like this. So that would just go in the body, C equals 0. Okay? I could put this outside if I wanted to, but I'm not. Okay? So this is option 1. This is how you can set C to 0 normally. Let me show you this. So I'm going to make a class C object called C, little c, and then I'm going to cout C dot, let's call it value or something. How about that? I'm going to output c.val and then a new line. So what should it be? This is a good test for you. What's it going to do? What's it going to print out? Zero, right? Because it's going to go in and call the constructor, set val to 0, and it'll print the val at the same time, right after. And it'll set it to 0. So that's option 1. Set value to 0 normally with a normal default constructor. Option 2. Initializer list. This is all you have to do. It's a weird, different kind of syntax, but this is it. You say C, parenthesis, parenthesis, and then you say colon, and then you use a constructor style initialization. You say val, I'm going to construct val with the 0 argument, and that'll set val to be 0. And now I can have an empty body. Isn't that interesting? You don't need a body now, because the work got done in the initializer list. We just set val to be 0 just like that. And again, does the same thing. Sets it to 0. And I can't remember if I showed you this already, but this is technically fine for any type, even ints. You can say int x with a constructor style initialization. It totally works. So yeah, that is initializer lists in a nutshell. If you had multiple things to set, like val and val2, you just say with a comma, val2 is 42. Okay. Maybe I'll make this 43. Okay, so it's going to output val, and val2 is going to set them just like this with the constructor style syntax after a colon and in between commas in a constructor. Okay, so that's the one thing I also want you to remember. Initializer lists only work for constructors. Okay, so that is the weird kind of syntax that you need if you're going to go and initialize a any member variable that itself needs a constructor call to get made, or any kind of const member variable. So for example, const int val3. It's way too late down here to go and set val3. Okay, what's the error? Can't assign to val3 with const qualified type. It's const. you can't change a const. Well, how does it ever get set? And the answer is Initializer Lists. That's fine. See that? Same with this, actually. Let me compile it and then show you. So yes, this works fine, but again, for the same reason, it's even too late in the body of the constructor itself to go and set val3. Isn't that weird? Read only. This is the only time right here in between this colon and this opening brace for you to set a const member variable. Same for calling if either of these were classes, to call its constructor. You have to do it in the initializer list. Okay? So it's weird. The more practice you get with it, the more comfortable you'll be. Okay? So it's also too late right here. If you want any hope at all, you need an initializer list, and you can keep the body empty. Okay? So hopefully, I know this is the weirdest syntax in the world, and we've just learned constructors too, but this is going to be very, very useful. Okay? And with the more practice you get, the more comfortable you'll be. That is definitely the answer. And as always, look for the sad face. Okay. Almost there. Almost there. So let's go back to this colon. That's an interesting concept. It has to do with this term called a namespace. Okay? And we say that every class gets its own. It's called a namespace. And I've talked to you about the difference between local variables and global variables. And this also goes back to the idea of namespaces. So each function has its own set, like main has its own variables, foo function has its own variables, bar function has its own variables, and they don't get to touch each other's names. Like you can overwrite, you can say, I have an x over here, and an x over here, and an x over here, and they're 3 different x's. They're local. They live in a different namespace. That's what we say. Those are clouds. And then global variables, they live in a different namespace altogether that's completely accessible. It's kind of like, this is the global namespace, so we can see everything. There's stuff out here. Okay? Classes. Classes get their own namespace. So they get their own methods, they get their own member variables, and we've been using this to our advantage because over here in counter, like we've said, okay, it's the getCount method that lives inside of counter. It gets its own namespace. It's counter's getCount. It's not like getCount defined outside like main is. Okay? That's what a namespace means. And the whole point of them is so that you can make 2 things with the same name and not have those names clash. Like for local variables, I can have a bunch of different x's and those names don't clash, even though it's probably bad practice to do that. So technically, the beauty of that is you can recreate your own versions of classes without using the class keyword, just using namespaces and structs. And you can put functions inside of those namespaces. So let me show you a silly little example, and I think that's enough. That's all we need. Okay, so I'm going to make a file called namespaces.cpp because I am very good with names, and here's how you do it. Here's how you make your own custom namespaces. Okay, you just say namespace, and then you give it a name. You can use standard if you wanted to, but that one already has enough in it, I think. So you can say namespace, I don't know, n1, and we can make functions in this. We can say, I don't know, int foo that returns 42. Yeah, and then we can make another namespace, n2, with another foo that returns 43. Yeah? And this is the beauty of it. No, I'd rather keep it like this. the beauty of namespaces is this lack of clashing. Because watch this. If I did this, if I put both of these functions out here for a second, this will not at all compile. Okay? And here's the error. It's like redefinition of foo. We can't have this. You already told me there was one foo. You can't go around and say that there's another two. That doesn't make any sense at all because this is the global namespace. You see that? This is not allowed. You're not allowed to have the same thing defined twice in the same namespace. And there is technically a little default namespace that's going on out here. Same reason you can't say int x and then int x. You have to use 1x. You can say x equals something else. You can reuse the x, but you can't redefine it. Yeah? So I think that's what I want to say. So this one can return 43 maybe. That's what I wanted to do. So now I can use both of these foos. They don't clash because they're in different namespaces. Okay? This is n2's foo. This is n1's foo. And here's how you call them. Okay? Essentially classes are doing this for you. They're packaging up structs and then special namespaces for all the methods. Okay? That's the whole point of a class, really, just to make this whole separation of concerns easy. This information hiding easy. Encapsulation easy. So cout n1's foo. Cout n2's foo. Yeah? There they go. So you're probably never going to need to make your own namespaces. Classes will do it for you. But I want to show you where they're coming from. Okay? It's essentially this. That's essentially what's going on here. And this is how the standard namespace was made. Everything that's defined inside of the standard namespace, it just has a namespace standard, and then everything's up in here. That's how they're doing it. Okay? So, again, nothing is magic. It's all... There's something in the language to do all this stuff that the standard library is doing and that I've been showing you. All right? So that's namespaces. And in the spirit of getting fancy, there's more to talk about. Okay? So this is a fun one. Let's do what's called operator overloading. All right? So I am excited to teach this to you. It's the weirdest thing, but it's very nice. Okay? So let's pretend we have two objects, C1 and C2. Yeah? Technically, well, maybe they were strings or something. Like if it was string C1 equals something, and string C2 equals something else. We don't care what they were. You know you can do C1 plus C2, right? But do you know what this plus means? It's not number plus, it's like string plus. How did this ever happen? And I also told you that strings are classes. What's going on here? So, here's the secret. Deep down, C++ translates C1 plus C2 into C1 dot, it's a method, C1 dot operator plus C2. Isn't that weird? Alternatively, if this one doesn't exist, if there's no method inside of strings for this, it will instead try and look for a function that's called operator plus with two parameters instead, just a normal function, and call it with C1 and C2, the thing on both sides. So secretly, it tries to find one of these methods, either this method or this function. And it's secretly called, like the name of the function itself is called operator plus. Okay? It's doing something weird. A secret translation is going on here. And it'll use whichever one exists. So, if you want C++ to be able to add points, for example, instead of using .add, so we had p1 or p.addq, right? And that gave back a new point. Wouldn't it be nice if we could just say p plus q instead? Isn't that nice? That's a lot cleaner. It's cooler looking than that, I think I can argue. So if you want this to happen, you just have to implement the operator plus, either as a method, so that it could be used like this, or as a function, so that it can be called like this. C++ doesn't care which one. Isn't that nice? So instead of, so we replace, we say, replace, it was called point, colon, add, and then it was like const, point reference, like O for other, right? Instead of this, replace it with, it's still going to return a point. It can still be a member function, but it's now called operator plus. And that lets us use the actual plus character. Isn't that awesome? Operator plus, and then we can give it const point reference O. Yeah? So, I don't know the best way to do this. Let's make it happen though. Here we go. So, well, I guess what I'd like to do is copy from last time the points stuff. Let's see if we can do that. Copy lecture 15, and it was in the point library. What else is there? We got point.cpp, I think, is the one, and point h as well. We probably need both of them, don't we? Well, let's just copy the whole darn folder then. Who cares? Let's copy it here. So now I have point lib again, and we're going to change it here. Are you ready? And let's make sure to go inside of point lib. And okay, so let's change point.h first. Here we go. So instead of add, let's make it operator plus instead of add. So instead of add, we're going to say operator plus, and that's essentially all you have to change. Instead of add, operator plus. Isn't this cool? And then in main, we didn't use it, but we can do it down here and say point p. I don't know, let's set it to 2, -3, because I got that right here. Let's add p to q, point q. This can be, I don't know, 3, -4, because why not? And let's add them together. S for sum equals p plus q. Secretly calls p.operator plus with q. Isn't that nice? Then we can output it s.getx space s.getY. New line. This is a nice little piece of syntax. That's a lot cleaner than saying .add all over the place. And if you ever learn a language called Java, this is one thing that I hate about it, because it doesn't have operator overloading. It does not allow you to do this. Hey. Why is it not happy here? Point dot see, there it goes. We'll call it main. 3, -4, is that right? Oh shoot. P, Q, S should have an X and a Y that is... Ooh, I think there's something wrong with our plus function. Oh shoot. Well, at least we're going to fix it now. What was it supposed to do? Ans.x equals x plus others x, y plus others y. That looks correct. Return ans. Why is this not happy? I'll have to look at it. Aha! So it took some debugging, but this was supposed to be Q and not P. Sorry if you're yelling through the screen at me. Now it's fixed. So it was giving back random numbers. It was setting random numbers into Q because I wasn't setting them. And those random numbers were actually very, very small integers, apparently, or very, very small double values. So now it should be happy. I'll show you how to debug in this fancy way soon. Much better. Okay, so I'm happy with that, and that is operator plus. So you could have done it also outside of the class. You could have done it out here. You could have just called it operator plus and not having belonged to the point class. That's totally fine. So if I don't go and implement that at least, let me show you how to declare it. You'd say something like, it would be point, alternatively, point operator plus, where it takes both sides. It's like const point reference x, and then const point reference y. Okay, that would be the alternative way of doing it. That is not a member function. It's just a normal function called operator plus, and C++ doesn't care which. Okay, so that is operator overloading. Isn't that cool? And then let me give you some examples for counter now. How about that? So I definitely encourage you to look up all the different kinds of declarations there are for operators. Actually, let me pull up the page so that you know where to go. Here they all are. There's a very long-winded page with all of these different kinds of operators that are allowed for you to use. Very, very interesting. Do plus, minus, star, all this stuff. Some ones that you haven't seen before. And they give examples. Relational operations that, of course, return booleans, right? Very, very fancy stuff. And let me put this here so that you have it now. Whee! That's a list. And yeah, let me show you counter. Let's do counter stuff now. Let's do plus plus instead of inc. That'll replace inc. That'll be fun. And then we can do other ones. But there are tons. You can do multiplication operator, less than operator, the shift operator, like what you give to cout, operator plus plus. That's what we're going to do now. Okay, let's do plus plus and less than. Okay, so let's do it. Are you ready? So let's quit out of all this, go back out here to look at counter again. So I'm just going to add this to it. We're not going to replace inc. Let's say void operator plus plus. Won't this be fun? So same as inc, but cooler to write. So we'll do operator plus plus. Here it is. So down here we'll do, oops, down here we'll do this, and it's counters operator plus plus, and it'll do count plus plus. And now watch me, I can replace all the inks, or at least some of them, with, it's not C++, unfortunately, the way that I implemented it. This operator is the before the C++, okay? That is what we just implemented. Isn't that cool? So that works instead of inc, and it's going to work still. It's going to do the same thing. Do I still have the counter stuff? Yeah. Oops. Try again. Yeah, still totally works. Now we made our own plus plus operator. Isn't that cool? And then finally, let me show you the less than operator, because that's a good one. That's a good one to have. Let's pretend that two counters, like here's counter C1, here's counter C2. C1 is less than C2 whenever the count inside is smaller. So that will be that C1 itself is less than C2, the whole thing, if their counts are smaller than each other. Okay? So let's implement that one. That is operator less than. And this takes another counter. Usually we'll take it by constant reference, call it other. And it returns a bool because it's true or false depending on whether the other one is smaller, or we're smaller than the other one. It's us first, okay? So this is return whether our count is smaller than the other's count, okay? That's how we determine this. And we're going to have to go and declare it as well. Dun dun dun. Oops. There we go. So this will compare two counters based on their count. Okay, so for example, did I make 2 counters? Yeah, I did. I made a C and a D. One has a 1, one has a 43. Well, it should be the case that, let's see here. It should be the case that C is less than D. That's true, so it should print 1 for true. Okay, and this didn't exist. This didn't exist without our implementation of the operator. Like greater than, for example, doesn't exist right now because we didn't implement it. It's like, what are you trying to do here? But we just made, out of thin air, we made the less than operation work for counters. Isn't that awesome? It's very, very cool, I think. And one last really cool thing about the less than operation in particular is that sorting is possible as long as your class has a less than operation. All that C++'s sort function needs to sort a vector of your class's objects, for example, is operator less than implemented for that type. Okay? Let's actually implement operator less than outside of the class, just so that I show you both kinds. Dun dun dun. Whee. It's exactly the same, but let me show you this way. So we're gonna compare 2 counters based on their count, delete, insert. And this one doesn't belong to the class anymore, we're getting it out of there. It's just called operator less than, and it's gonna take 2 now. I'll call it X and Y maybe. And so now, because this is outside of a class, it needs getters. We need to say get count, or sorry, X dot get count. Check if that's less than Y's get count. And this still works. It's still, it's not a member function anymore, but it's still an operator, and it's going to work on counters. So nothing changed. Okay, we just had to use the getters now because we're not in the class anymore. Okay, so now for my final trick, let me make a vector. And then also, we're going to need the sort function in algorithm. So vector of counters, because why not? Let's put D before C, and watch it output them both in opposite order. Watch this. So let's see here. Now I have to give it a name. V. Here we go. Here we go. Are you ready? I can sort this. No, sorry. It's sort v.begin, if you remember the style, v.end, and that is all. And now v is sorted. We can make sure of it. We can say for counter C in V. We can say, all right, C out that counter. Well, I've used it. Let's say CNTR or something, so that I don't confuse it with the C out here. We can output the counter's count, and then maybe a space. What do you want to bet that C is now first? Because C had a smaller count at the end of it. It was 1 then 43, yeah? Not 43 then 1. It'll have swapped them. The sort function will have swapped them. Because it knew when 1 was smaller, because we implemented the less than operator. It's all come in full circle now. Isn't this fun? Okay, so that was a lot. I encourage you to study all of this stuff that we wrote today. It was a lot of stuff, and it's all very useful. Okay, it's all going to come in handy. Okay, so I encourage you to take a look at all this a little bit more, and that is all that I have for the content for today. I do want to pull up the mid-semester evaluations, which are anonymous, because that is something just for me. Okay, so I'll be right back, and then we'll be out of here. Okay, so we are halfway through the semester, essentially. It's week 8. There's like 17 weeks or so, right? So let's say we're at the mid-semester point, and I'd like you to evaluate the class. And this is anonymous, and it's just for me. It's not required at all, but I would appreciate it if you did it, okay? So here in the week 8 module, there's this mid-semester anonymous feedback link. If you click on that, It'll have a link to the survey on Google Forms, and please respond to as many or as few questions as you would like. Okay, it's just for me. Everything's anonymous. I can't tell what you're saying or who said what. It doesn't matter. This is just for me to get better as an instructor. Okay, so I would encourage you to fill this out if you had the time, and yeah, take my thanks if you do. I think that's all I have for you. So we've come very far. I have a fun little example next time at the very start, but we are essentially done with classes now. You are a master. There will be a little bit more in the Xi book as you read it. You'll see a couple more cool things, but this was the bulk of it. You are now masters. So I think that's all I have for you, and I will see you in your lab.